In this lesson, we're going to be looking at both combinations and permutations. We're going to look at the formulas for each and see their connection. We're going to be able to determine if a problem is a permutation or combination situation. And lastly, we're going to use the calculator to calculate combinations and permutations. All right, before we move into those formulas, we do have to make sure we know what a factorial is. So here is our definition of a factorial. We basically start with the number n and keep multiplying by the numbers that come before until we end up at 1. So for instance, if I'm working with 5 factorial, that's 5 times 4 times 3 times 2 times 1. So let's see, 20, 60, 120 would be my answer. If I'm working with 4 factorial, 4 times 3 times 2 times 1, so that's 24. 3 factorial, 3 times 2 times 1, which is just 6. 2 factorial, 2 times 1, simply 2. And 1 factorial, which is just 1, so it's just 1. All right, now in some problems we get something called 0 factorial, which often doesn't make any sense because how can we start at 0? You might think that would equal 0. In your book it's going to say by definition it equals 1, and I just want to show you how in a pattern it also equals 1. If I am going from 120 to 24, I can divide by 5 to get there. And from 24 to 6, I can divide by 4. And from 6 to 2, I can divide by 3. And from 2 to 1, I can divide by 2. So following this pattern, I would divide by 1, and then 0 factorial indeed comes out to be 1. This is going to come up in a later problem where we use 0 factorial. So it's really important to remember that 0 factorial equals 1. All right, for permutations, we did permutations yesterday, but we also have a formula that's a little different than the way we did it yesterday. And our formula is n factorial over n minus r factorial. In permutations, order matters. So a, b, and ba are completely different answers, so we have to count them separately. N is the total number of elements, and R are the number we are choosing. And in this formula, there can be no repeats. So some problems yesterday had repeats. You could not use this formula to work with those. All right, so let's take a problem similar to yesterday's, where we were asked how many ways could we arrange the letters to Irondale. There are 8 letters, so you might recall we did 8 times 7 times 6, 5, 4, 3, 2, and 1, and we said, oh yeah, that's 8 factorial, and we got that large number. We could also say this is a permutation. I'm choosing 8 of 8 letters, and if I use the formula, which was n factorial over n minus r factorial, we're going to have on top 8 factorial, and on bottom we're going to have n minus r. Well, n is 8 and r is 8, so 8 minus 8 is 0 factorial, which we just said was 1, and we get the same answer that we had yesterday. Now let's look at this one where we would say just arrange 3 letters. So yesterday we would have said, okay, I have 8 choices for the first letter, 7 for the next, and 6 for the next. And our answer was simply multiplying those 3, so 8 times 7 times 6, and we get 336. If we use the formula, I just want to show you that we'll get the same answer. Here we have 8 permutation where we're choosing 3 of the 8. On top, so this is n and this is r, we have 8 factorial. And on bottom, we have 8 minus 3 factorial. And so we have 8 factorial over 5 factorial. Now this comes out to be the same thing as this over here, because what really happens is on top we're taking 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, the 5 factorial basically divides out all the choices we're not going to use. Since we're only picking 3, we're not going to use these, and these all cancel. And there we go. We get that same answer of 336. And you could put 8 factorial divided by 5 factorial in your calculator. All right, so now we have combinations, and that's going to be new today. And in combinations, our formula has one more thing in it, and that's this r factorial that we're dividing by. So let's explore why that's the case. Now the thing is, in combinations, order does not matter. So AB and BA are the same combination, so they count as one case. count as one case. And so we have to divide by r factorial. This is the number of repeats. So number of repeats in different orders. N is still the total number of elements, and r is the number of elements chosen. So let's look at an example. So we're going to go back to Irondale, and we're asked how many combinations are there that use 3 letters in Irondale, just like before. But remember, all of these, RON, NOR, NRO, RNO, they're all the same. And in fact, we should ask, how many repeats are there going to be? Well, if I took 3 letters, well, for the first one I have 3 options. For the second one I have 2. For the third one I have 1. And so I have 6 ways of choosing, or ordering, I should say, ordering Rn and O. And that's why I would end up dividing by that 3 factorial. So let's try out the formula. It was NCR. On top we had n factorial. On bottom r factorial. And n minus r factorial. So this is all the ways to, this orders all of them. This one divides by the unused ones. And this over here divides by the number of ways they can be arranged. Number of ways arranged. So that, remember, in this case, all of these are really the same case. All right, so let's try this out. We have 8C3. On top we have 8 factorial. On bottom we have 3 factorial, because that's our r. And then we also have 8 minus 3 factorial. So we've got 8 times 7 times 6, 5, 4, 3, 2, 1. Over that we have 5, 4, 3, 2, 1. That was from the 8 minus 3 factorial. And then I also have 3 factorial. 3 times 2 times 1. And then we'll see that these all cancel. And 3 times 2 is the same as 6. And we end up with just 56 ways of choosing 3 of 8 letters. Now this looks like a lot of calculations, but it turns out we can also do this on our calculator. So here are the 2 screens you're going to be looking for. The first one is in your math menu, and you go all the way over to probability. So you choose math, and then you go to probability, and there you have your permutations, your combinations, if you need it, your factorial. And so if I want to do 3 of 8 with permutations, I type in 8 NPR3. There's that answer we had, 336. And if I want to choose 3 of 8 with combinations, I type in the 8 combinations 3 and 56. This would be a good time to pause and make sure you can do that before you move on. Okay, so now let's look at these next 2 problems. The first thing we need to do is figure out if it's a permutation or a combination. And just a reminder that in permutation, order matters. All right, so in this first question, we're asked how many ways can 3 representatives be chosen from a class of 30 students? Now representatives, I don't think it matters if I choose Alice, then Bob, then Carl, or first I choose Carl, then Bob, then Alice, or Alice, Carl, then Bob. It's still the same 3 representatives. So this is a combination problem because the order does not matter. And so now I'm choosing from 30 students, C3. And now I can go into my calculator, and let's put this in, 30, math. If I arrow left, I only have to go once over, choose C, enter 3, and look at that, we've got 4,060 different ways we could choose those 3 representatives. Now in part B, we're asked how many ways can a president, secretary, and treasurer be elected? Now here order is going to matter because it's going to be different if Alice is president or Bob is president or Colin is president or if, who's the secretary. So being a president, secretary, and treasurer, it might be the same 3 people, but if they're in different roles, that's going to be a different situation. So this is a permutation problem. So now we're going to go 30 P3. And so same idea, 30, math, arrow to the left, permutation 3, and now we've got 24,360. In general, your permutation answer is going to be larger than your combination answer because every different order is another case. All right, so now let's look at a problem like this. Let's say we have a candy bowl and it only has 5 bags of Skittles and 3 bags of M&Ms left. And you're putting your hand in, reaching in without looking, and you're going to pick up 2 bags. And we're going to say, okay, how many different ways could you pick up 2 bags of Skittles? Well, there are only 5 bags of Skittles, so we're going to do this. We're going to be picking 2 of those 5. And of course, there's a bunch of different ways we could do it. Now, it doesn't matter what order, because if I get Skittle bag 1 and 4 or pick 4 and 1, I really pick the same 2. So this is a combinations problem. I'm looking at how many ways can I pick 2 of those 5 bags. And so let's get an answer for that. So we've got 5 math, C, 2, and we've got 10 different ways we could pick 2 of those 5 bags. What are the different ways we could pick 2 bags of M&Ms? Well, this is going to be 3C2. There are only 3 bags of M&Ms, so we could pick the first and the second and the third, or the first and the third. Well, I think the answer is 3. Let's go and check on our calculator. 3 math, let's see, C2. There we go. I was able to list the 3. Now in this next one, how many ways could I pick 1 bag of Skittles and 1 bag of M&Ms? Well, let's see. I have all the ways I could pick 1 of 5 times all the ways I could pick 1 of 3. Now these are obvious. If I'm choosing 1 of 5, there's 5 ways. If I'm choosing 1 of 3, there's 3 ways. And going back to that multiplication principle, I'm going to multiply those two, and I have a total of 15 different ways that I could pick a bag of Skittles and a bag of M&Ms. Oops. All right, in our last example problem here, we're looking at a situation where a class has 15 seniors and 7 juniors. The teacher wants 2 seniors and 2 juniors to lead a charity drive. How many ways could those students be selected? So this is similar to the last one we were doing. And in here, we are first figuring out all the ways we could choose 2 of 15 seniors. And we also want to figure out all the ways we could choose 2 of 7 juniors. And then every choice here gets multiplied by every choice here for the total number of options. So here we go. 15 math, let's see, combinations, 2. So we have 105 different ways of choosing 2 seniors. So this is our 2 seniors. And then we look at all the ways we could pick our 2 juniors. 21 ways, and now we just multiply those two numbers. So 105 times 21 gives us a total of 2,205 ways to choose 2 seniors and 2 juniors to lead this charity drive. All right, with that, we should have enough information in order to do our homework, section 8.4 in these problems.